Good morning, students. Welcome to Good Samaritan School online classes. In this video, we're going to learn about how the formation of ionic compounds are formed in the compounds like magnesium oxide and sodium oxide. And this calcium oxide, you're going to do an example and you're going to do as an homework. Okay. Let's see how these two compounds, magnesium oxide and sodium oxide, forms an ionic compounds or ionic bond. Okay, just I want to give a recap of what we learned in the last class. The last class we learned about how do metals and non-metals react with each other. In that, we learned all the metals and non-metals, their only goal is to attain the noble gas configuration, that is an octet configuration. For that, what metals will do? They try to lose some electron to attain the octet configuration. And the same non-metals also, they try to gain some electrons from metal and try to attain the noble gas configuration. So this is what we learned in the last class, and we tried with the example of sodium and chlorine to form sodium chloride. And today we are going to do the same thing but with some other examples. And the first example that I have taken is magnesium oxide. You look at the example of magnesium oxide, we have magnesium and oxygen. Magnesium, if you watch carefully, magnesium atomic number is 12, right? Magnesium atomic number is 12. And the electronic configuration of magnesium is 2, 8, 2. That means 2 in the first shell, 8 in the second shell, and 2 in the last shell. So if you look at it, magnesium needs 6 more electron. That means it has to gain 6 more electron to form the octet configuration. But in the other way, if it loses this 2 electron to some other thing, or it loses that electron, then it will attain the noble gas configuration, right? So it is easy for magnesium to lose the 2 electron instead of gaining 6 electron. So what this magnesium will do, it loses 2 electrons, giving the 2 electron, and it forms 2 plus. Why this 2 plus comes? Because it loses 2 electrons. So after losing 2 electron, the first shell is already there, filled, second shell is already there, but third shell is only 2 electron, that is going out. So after losing the 2 electron, now it has only 8 electron in the outer shell. That means completely filled octet configuration. So now magnesium is attaining the octet configuration. That means noble gas configuration. Now go for the oxygen here. Oxygen has 2 in the first shell and 6 in the last shell. That means oxygen's atomic number is 8. So 2 in the first shell, 6 in the last shell. So how many electron this oxygen needs to attain the octet configuration? One thing, it needs 2 electron. After gaining 2 electron, it becomes 2, 8. So now it attained octet configuration. What is the other thing? Oxygen needs to lose all the 6 electron to form an octet configuration. Then only this 6 electron goes out and 2 electron will be there in the first shell, so it become octet configuration. So which is more easy? Either losing 6 electron or gaining 2 electrons. Yes, gaining 2 electrons. So what happened? Oxygen gains 2 electrons plus 2 electron. That means gaining 2 electron, and it forms 2, 8. That means 8 electron now comes. 6 was there, but after adding 2 electrons, it become 8 in the last shell. That means it gains 2 electron. That is why we write O 2 minus. This 2 minus represents this negative sign represents gaining of electron. That is what we are writing it here, gaining 2 electrons. Okay, these two are the ionic equation that you have to write it properly. If you will not write this 2 plus or 2 negative here, which is given in magnesium and oxygen, that means you will not get the complete mark. So you have to mention this. how many electron is they lose, how many electron gain, that also very, very important. Okay, let's try with the dot structure. How the dot structure we have to write. Magnesium is having atomic number 12. That means in the last shell it has 2, 8, 2. That means 2 in the last shell. To mention the 2, I am writing that 2 dots here, because 2 dot are 2 electrons in the last shell. Clear? And then what happens? This oxygen you know that atomic number 8. So it has 2, 6. 6 in the last shell. So we are mentioning only the valence electron. So valence electrons are very important, and you all know that in the 9th standard we learned only in the valence electron the electrons transfer is taking place. So what happened? 2 in the last shell, I have written 2 dots. To mention a different sign, I put a into mark for oxygen. So 6 electrons, 1, 2, 3, 4, 5, 6. Now what happened? This magnesium is giving the 2 electron to oxygen. After losing the 2 electron, magnesium now form 2 and 8, receiving the octet configuration. After gaining that, you see that magnesium now becoming 2 and 8. That means 2 electron goes out. That is why it is attaining 2 plus. Magnesium lost 2 electron. And oxygen, what happened? After gaining this 2 electron from magnesium, now you count the number of electron in the last shell. 1, 2, 3, 4, 5, 6, 7, 8. It became an octet configuration. That means gaining of 2 electron. That's what here mentioned. Magnesium 2 plus is a cation here, positive, or in other word metal. Oxygen 2 minus is an anion. In other word, it's a non-metal. Always the metal has a tendency to gain an electron, and the non-metal have the property of metal have the property of losing an electron, and always a non-metal have the property to gain an electron. This you have to keep it in your mind, right? Okay, we'll go for the other example. Let's try with sodium oxide. Sodium oxide, same procedure. First I am writing the ionic equation, and then we are going to do a dot structure. Sodium, we have 2 sodiums here. You have to look at carefully. Na2O, that means sodium has 2 and oxygen only 1. So 2 sodium, 1 sodium is having atomic number of sodium is 11. So electronic configuration is 2, 8, 1. Okay, we are doing it for 1 sodium. That means sodium have to give this 1 electron, then only it attain the octet configuration. So what happens? Sodium, after giving that 1 electron, here 1 electron, it become 2, 8. And why I have put in 2, 2 here? Why I put 2, 2 here? It means we have 2 sodium. Okay, 2 sodium. Each sodium is having 2, 8, 1 electronic configuration, and each sodium is losing 1 electron. And after losing an electron, each sodium is getting 1 positive sign. And how many electron it loses? 2 electrons. Will you understand? Here it is not, here it is not 1 electron. Each sodium is losing 1 electrons. Okay, that is why we are mentioning it as 2 electrons. And oxygen also, they have the same last time we did. Oxygen 2 and A6 is the electronic configuration, because oxygen's atomic number is 8. Okay, 2 in the first shell, 6 in the last shell, and it needs 2 more electron. That is why it adding 2 electrons, it become 2, 8. This is forming oxygen 2 minus, gaining 2 electrons. Why I didn't put Na2 plus? I told you it is not 1 sodium, we have 2 sodium. Okay, I cannot write 2 plus. Magnesium losing 2 electron means I can write like this, Mg2 plus. It means only 1 magnesium losing 2 electron because electronic configuration is 282. Okay, it loses 2 electrons, so I am writing it as 2 plus. But sodium, we cannot write 2 plus because sodium last shell, how many electrons are there? Only 1 electron. That is why I write it as Na plus. But here, how many number of sodium here? We have 2 number. Okay, so let's see the dot structure. There you will understand more on how it forms. Okay, let's see this dot structure. Sodium, as I told you, we have 2 sodiums here, Na and Na, 2 sodiums, and it is going to react with 1 oxygen. And each sodium 281, okay, here also 281. This sodium is electronic configuration is this, and this sodium electronic configuration this. And each sodium is having 1 electron in the last shell. That is why we are mentioning it as 2 dots. These 2 dots represents 2 electrons. That means each sodium's last shell electrons. And these electrons are given to oxygen. And oxygens, you all know that the electronic configuration 2,6. That means it needs 2 electrons. Needs 2 electrons. So that is why each sodium is giving 1 electron to oxygen. After gaining that 2 electron, we get like 2 sodium is getting plus symbol. As I mentioned above, we should not write 2 plus because one sodium is giving only 1 electron. Here we have 2 sodiums and giving only 1 electron. So 2 sodium is giving 1 electron. So I write plus. And then after receiving this each electron from each sodium, oxygen will become, already oxygen is having 1, 2, 3, 4, 5, 6 electron. After receiving 2 electron from each sodium, it becomes 2 minus. So either you can write like this also, Na2O. But this is the dot structure. In exam, this is also one of the very important question. Why we are doing this topic again? Because this is another very important question for your board. Okay, it comes in 2 mark or in 3 mark question. Okay, so it's most important one. Okay, student, most of you would have understand this. If still you find any difficult on this topic, especially on reaction with metals or non-metal, especially on ionic equation and dot structure, please ask me in my WhatsApp personal number. And I'm going to give you some homework for you. And this is what the homework: calcium oxide, aluminum chloride, and calcium chloride. This you are going to do as a homework, and you should write both ionic equation and the dot structure. Okay, student. Okay, finish this and send it to my personal WhatsApp number. And thank you and have a nice day.